Hi everyone, my name is Naila Morita Chakravyun. My student number is 2024-32051. Okay, in this video, I'm going to walk you through my Java programming task on the concept of inheritance, especially focusing on geometric shapes or bangun ruang. So let's break down to the process step by step. Okay, first thing first, we start by declaring the package inheritance bangun ruang and think of this as a folder that keeps all our classes organized and easy to manage in one place. Okay, next, the step 2 is I create the parent class named Bangun Ruang, and this class represents the general concept of geometric shape that will be inherited by other specific shapes. The step 3 is attribute definition, and I define the attribute nama or name as a string. I use the protect modifier. It can be accessed by subclass while maintaining encapsulation. The next step is parent constructor. I create a constructor. This step, I create a constructor for the Bangun Ruang class. Its job is to initialize the name of the shape using this keyword the moment we create an object. Okay. The next step is the tampilkan nama method. I also added a method called tampilkan nama, and this is a general method designed to display the shape's identity. Because it is in the parent class, I don't have to rewrite the code for every single shape, and this is a great example of code realizability. Okay, next. The next step is defining volume in the parent class. And finally, in the parent class, we have the volume method. And since every shape has a different formula, I set it return a default value of 0. And this method is basically a placeholder that will be overridden by the child class's letter. Okay, the next step is declaring the child class or kubus. And let's look at the child class is kubus or cube. And notice the keyword extends, and this is officially make kubus a child of bangun ruang, and meaning it inherits all the traits from its parent. Okay, next is make private attribute. For the cubes, especially, I added a CC or side attribute, and I set this to private to apply the principle of encapsulation, ensuring the side length data is protected. Next is make a cube constructor. In the cubes constructor, I use supercubus, and this is the child class calling the parent's constructor to set it name to kubus, and after that, the specific side value is saved. Next step is overriding the volume method. Here's the most important part because I rewrite the volume method using the actual cube formula, and override ensures Java use the specific formula instead of the one from the parent. The next step is create accessor method or getCC. Since the CC attribute is private, I create a getter method called getCC, and this is the professional and safe way to access that value from outside the class. Next, the next step is testing and output. For the testing and output step, we create main class and method, and I create a class named main with the main method, which serves as the starting point from the program to run. And the next step here, I create a new object called Kubus with a side length of 5, and this line automatically triggers the constructor we built earlier. Next is the step 15, we calling tampilkan nama, and when I call Kubus tampilkan nama, the program runs the method from the parent class, and this proves that our inheritance setup is working perfectly. And lastly, I print the side length using getCC and calculate the volume, and this demonstrates polymorphism in action as the program uses the specific volume logic belonging to the cube class. And this is the output analysis. As you can see on the screen, the output is perfect because the shape type is kubus, the side length is 5.0, and the cube volume is 125.0. And the build successful message confirm that everything is running without any errors. Okay, that explains the steps of creating an inheritance program for geometric shapes. I hope this was clear and helpful. Thank you for watching. I'm Naila Amrita Chakra Rafiun. See you in the next video. Bye bye.